Hi everyone, and thank you for being a part of our today's webinar. My name is Max Bondarenko, and I'm Marketing Director at Cybervision, the company behind the platform. During the webinar, we're going to disclose some of existing business opportunities enabled by the Industrial IoT and how can they be effectively achieved with the car IoT platform. The Industrial IoT is the key driver behind the Strategic Industry 4.0 initiative, which is going to be massively implemented worldwide. The key principle of the Industry 4.0 is transforming hardwired machines into smart cyber-physical systems capable of interoperating with each other, managing real-time data, and flexibly reprogramming themselves on the fly. As you can see, the Industry 4.0 encompasses a variety of technologies, but the Internet of Things is the key driver for implementing nearly all of them. IoT-powered connectivity between sensors, machines, and systems is the very foundation of which new manufacturing will be built. Only German industry alone is projected to invest a total of 40 billion euros in the Industry 4.0 every year by 2020. So the stakes are high and the path is not yet well trodden. We'll chart some clear directions for you during this webinar. I would like to mention a few things before we start. Please post your questions in the corresponding window that is present in the admin panel on the right side of your screen. Make sure to stay until the end of the webinar, as we will spend a few minutes to answer them after we finish with the presentation. We will also post them on our website, which is carproject.org. Also, please subscribe to our YouTube channel for more great videos and tutorials. Now, let me introduce Andrew Kochanowski, Chief Technology Officer at Cybervision, who will lead our today's webinar. Andrew, take it away.
Thank you, Max, and I appreciate everyone from numerous time zones accommodating us in your schedule and joining the webinar today. As Max pointed out, there is a lot of hype happening today around Industry 4.0 and the Internet of Things. However, a strong use case is the winner every time. So what I'd like to do today is to guide you through the various use cases that really work in Industrial IoT from our own project's experience with the car platform. In the modern industrial setting, equipment, PLCs, vehicles, automation systems, sensors can all be connected together to enable better monitoring, control, and automation capabilities. For those of you who are new to car, this illustration demonstrates how the platform fits into this environment. As you can see, the picture is broken into three layers: hardware and equipment at the bottom, application geared towards various users and audiences at the top. Simply put, everything happening in between is handled by CA. CA acts as a middleware or glue that manages data flows and makes it possible for companies to deploy and operate intelligent, real-time IoT solutions. But first, let's put it all into the right perspective. Let's look at the main business aspects of the successful IoT implementation. There are numerous benefits of the Industrial IoT, but we'll focus on the major ones that drive direct business value. So the IoT is blooming in the industrial sector because it increases companies' revenues through improved asset utilization and through the introduction of new, smarter products. It reduces their operational costs, improves customer satisfaction and worker safety, and last but not the least, enables more efficient energy and resources utilization. So let's go ahead and see how to best achieve these benefits, starting with our first example. Let's talk about the key use cases, starting with the maximized uptime. When production processes are interrupted, the customer loses money. Even if it's only minutes per month per machine, when it adds up significantly if we talk about a large fleet of industrial machinery. For some systems, like a power plant, a military system, or an oil refinery, a failure is not an option at all. The Industrial IoT can shield industrial systems from downtime in multiple ways, but it all boils down to detecting the earliest signs of malfunction and preventing their aggravation. Installing IoT sensors into industrial systems allows operators to know what's going on with the equipment in near real time and with high accuracy. connected through middleware like Ka, these sensors provide you with an in-detail reporting over the equipment status, performance, security, and so on. Conducting regular equipment health checkups gets easier too, since a big chunk of work can be done remotely and with greater accuracy. When we can predict problems, we can prevent systems going down. With the IoT, every single machine can be transparent to your eye. The field operations are the ones to experience most dramatic quality impacts from embracing IoT. The telemetry data collected from equipment is a rich source of actionable information for technicians. Based on the analysis of the telemetry data, the field ops may take an informed decision whether a piece of equipment requires any service. That is a major improvement over the old modus operandi with massive overservice and excessive truck rolls. Even for the cases when the service is actually required, the efficiency is largely improved by more precise and expedite failure root cause analysis, powered by sensor data and the electronic service history record. That results in a better customer service satisfaction and loyalty. However, with IoT, you no longer even have to wait for failure to occur. In many cases, proper analysis of data feeds coming from the equipment can lead to indications of possible future malfunction, and proper preemptive maintenance action can remedy the incident even before it happens. Businesses which provide warranty-based maintenance services on the equipment they sell or lease know very well that their customers often take advantage of the warranty-covered period for their equipment by pushing it to extremes. Some companies report warranty service costs to chew up to several % of their annual revenue, which can be huge. They also have a hard time validating warranty claims because they lack vital equipment operational data. Now, IoT can dramatically improve their success rate in correctly validating claims and even allow for informed extension of the warranty that is safe because it is based on real-life data. Having the IoT solution implemented, the data from sensors or devices embedded into the operational equipment can be collected throughout its life cycle and then analyzed to detect potential equipment misuse. Even without a physical inspection, this information may be sufficient to validate warranty claims, suggest a safe warranty extension period, and estimate the price that would cover potential extended warranty costs. According to the World Economic Forum Industrial Internet Survey, optimizing asset utilization ranked the top reason to adopt industrial IoT technology, with 79% of respondents citing extremely important or very important for near-term adoption. By connecting equipment into the IoT cluster, it is possible to automate performance analysis and calculate key performance indicators in real time. Small to medium-sized manufacturers can afford such analytics too, reducing the gap between them and the high-profile market leaders in terms of production performance. Using historical data, the production planning becomes also more accurate and fast. Additional cost savings can come from better energy practices, managing the energy usage for peak, off-peak, and zero service periods. Real-time alerts are another handy tool to keep hand on pulse of what is going on with the systems and services. They can help you react instantly if abnormalities take place and have peace of mind all over time, knowing that everything operates as it should. Because machines are able to pinpoint and communicate detected issues, engineers spend less time on locating them and more on troubleshooting. Consider an example of a machine going down and sending an automatic alert to the service manager, based on the policies set and who is subscribed to the feed. That manager can get an instant alert on his or her mobile device, including a map that shows precisely where the machine is located. This is tremendous, particularly at large locations. An alert can also feed into a ticketing system, so that when the manager fixes the problem, he or she can close the ticket. It gets even better with control automation, in which case an alert can trigger an incident handling scenario that will immediately and automatically mitigate the failure and prevent further damage. Data collected from production systems is of great value to product and innovation teams because it allows them to understand the equipment behavior and performance outside of the lab, and also identify common usage patterns. This knowledge is vital for improving the existing products and creating new, more competitive ones. By looking into the equipment operations through the eyes of a user, not only can you offer better functionality, but also more superior user experience. Now, in the world of smartphones, users and organizations often take over-the-air updates for granted. And yet, vast majority of the industrial equipment keeps running software dating back to decades ago. In many machines, the software upgrade capability is not even possible, while in others, prohibitively laborious and thus expensive. Implementing an over-the-air software update into industrial equipment, now possible with IoT, gives the vendor a distinct competitive edge. OTA enables almost labor-free and timely rollout of software upgrades to connected equipment, validates installation, and allows keeping track of the update's history, maximizing lifetime equipment value to customers. Imagine the manual labor cost savings realized when applying updates across the fleet of thousands of machines. Making industrial machinery more programmable and adaptable is a key principle of the Industry 4.0 and the Industrial IoT. This will make each machine much more versatile and productive. Speaking about the factory as a whole, smart connected factory floor allows producing greater range of goods faster and more reliably, and also introducing new products into production in a fraction of the time it used to take. Using embedded computing, every part of the factory floor can be flexibly manipulated through applications, cloud services, and plugins. Physical, hardwired configurations that take days or weeks will become the thing of the past. These applications are already utilized in industrial robots, but with large-scale IoT implementation, production facilities which will be much more programmable and faster to change between different production modes. Now, when we consider the usability factor, the IoT-enabled equipment wins hands down because it provides users with intuitive software interfaces. The ones that can be used through a web browser, on a tablet, on a smartphone. Rich capabilities of these applications ensure the most productive and comfortable user experience. The IoT-enabled equipment provides users with greater flexibility, allowing them to apply a variety of customizations over IoT-powered equipment, such as widgets, workflows, notifications, charts, user interface, and so on. Importantly, consistent user experience reduces the new employee learning curve, improves productivity, and safeguards against needless errors. With the constantly increasing complexity of industrial equipment, it is crucial to keep user interface as intuitive as possible. According to the International Labour Organization, somewhere in the world, a worker dies every 15 seconds from either a workplace accident or from an illness or disease caused by their workplace. In the same 15 seconds, 153 workers will have a work-related accident. That's a staggering 2.3 million deaths and 317 million accidents every year. That's where IoT solutions can make a big difference. Detecting malfunctions, fire, and toxic leaks early can prevent a large part of factory accidents. The IoT can also be used for timely contextual notifications and smart safety prompts to minimize risk of negligence. Relatively easy to implement, the IoT solutions are now the easiest way to make a working environment much safer and comfortable. Other crucial use case that can be enabled with IoT is perimeter security and also internal physical access control. Unauthorized access to production facilities bears a high degree of possible harm both to production and equipment, and also can be hazardous to an intruder. So the first step is to prevent external intrusion by using sensor-laden perimeter security. Then implement internal security zoning using sensors and real-time monitoring. With IoT, indoors positioning, and authentication technologies, it is possible to ensure proper authorization of personnel accessing specific areas within the facility. Further, violation of access rules can immediately fire an alarm, resulting in appropriate security measures. Finally, let's address the theme of sustainable production and efficient utilization of energy. Smart lighting is the major breakthrough in terms of saving energy for industrial companies. In some cases, it allows cutting energy spending by half. Accurate measurement of resource utilization by applying smart meters is the best way to address cost optimization and sustainability problem. Applying IoT sensors and smart meters, you can also ensure that your production meets all emissions metrics and prevent unintended or accidental pollution of environment. That's the case when economic benefits positively correlate with the greater good. So this concludes the list of selected industrial IoT use cases we wanted to present today. Max, take over.
Thank you for your time with us today. Please remember to visit our website where you can find more webinars, get detailed information about KA, and download the platform. For all the commercial and partnership inquiries, please visit our Contact Us page and select the corresponding department in the forum. Thank you and take care.